Here, and we are going to solve these t-test practice problems that I've posted on the iCollege website. So let's read this first one. As a coach, you randomly assign your players to two teams. Team A train the old-fashioned way. Team B uses computer assistance. The number of the minutes needed to run around the track once. Do the data show there's a significant effect of training type? Follow all the steps used in hypothesis testing. Well, as you see, I've got a Google Docs spreadsheet open here, and this works exactly the way Excel does, at least for the functions that we've been using. And so I'm going to set up these columns here, Team A and Team B. And I'm going to input the data first, and then I'm going to walk through all the steps that we do when we're testing a hypothesis. So 11, 7, 6, 12, 12, 8, 18, and 12. And then on Team B, these are minutes needed to run around the track once. And Team A was old-fashioned. Team B is computer-assisted. 1, 3, 4, 3, 6, 4, 3, 4. Okay. Let's write out, first of all the steps that we're going to need to follow in hypothesis testing. So 1 is state the null hypothesis. So here it's that mu1 minus mu2 equals 0. All right, can't do the t-test without that null. 2, oh, it didn't give us an alpha or tails, but I'm going to say that alpha is 0.05, and we'll do 2 tailed. You know what we might as well do right now is look up our t-crit here. And in order to do that, I'm going to need these sample sizes, right, for each group. So Team A, we had n equals 1, 2, 3, 4, 5, 6, 7, 8. N equals 8. That means degrees of freedom are 7. And up here for Team B, same. N equals 8. Degrees of freedom are 7. And that means the total degrees of freedom here, right? And I'm going to put this in parentheses after t-crit. It's going to be 7 plus 7, which is 14 pooled degrees of freedom. And that means we can now look at our t table in the back of our textbook. So get used to seeing this column. This is the one proportion and 2 tails combined. Here's the level of significance 0.05. And for 14 degrees of freedom, going across here, the critical value for 2 tails will be plus and minus 2.145. So let's put that in here, 2.145. That's a step we can do in step 2. We don't have to look up t-crit at the end. We can do it right now. Let's go back to the question. And what is step 3? Calculate t. And in order to do that, we need our formula sheet. So our formula sheet is back here somewhere. There we go. There's the formula sheet. I posted this on iCollege too. Okay, so t is the difference between the two sample means. So let's get that first. So these are the means. All right. How do we do means? Say equals average. And then we're going to just select all of our scores. All right. You can copy and paste this. Yes, yes. I know how to copy and paste. Okay, we'll copy and paste this. Big difference between the means, right? Longer time for Team A, shorter time on average for Team B. Let's bold these just so that we know those are means. And we're not going to include those when we select all the scores again. Okay, now we've got the mean difference. This population mean difference we already said was 0 here in the null hypothesis. So we really need the estimated standard error, the difference between the two means, which is shown here. Well, to get that, we need the pooled variance. And to get pooled variance, we need sum of squares. So let's set up our spreadsheet to do sum of squares here. I'm going to insert 2 columns here for deviations and squared deviations, and I'm going to label them that. A little shorthand there. We'll copy these over to here. All right, what's the deviation going to be? Well, deviation of the score 11 from the mean. I'm actually going to click on this cell, but I'm going to make it a static reference so that it's always going to reference cell B11, and it's not going to like go down to the next cell B12 when I paste it in the cell below. All right, great. So let's copy. Yes, 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 I know. Let's copy and paste. Those are our deviations. Let's do the same thing over here. The deviation of cell E3 from the mean, we subtract this, but again, we're going to make this a static reference using the $sign. $E, $11, right? And that gives us that value. We'll copy and paste that there. Okay, so to square that, we just say that deviation raised to the second power. That's shift 6. And then we copy and paste that to get our squared deviations. Whoopsies. There we go. And we'll actually paste that over there too. So I'm pasting the same thing that I copied because it'll update that cell that it's squaring relative to the cell next to it. See? Okay, there we go. All right, the next step is to sum those squared deviations. All right, I'm actually gonna align that to the right. Same thing here. Okay, so we'll sum these squared deviations to get SS1. Let's label that properly, SS1. SS2 is the same thing, so we'll copy the sum and we'll paste it over there. So we've got SS1 and SS2, make that bold. We've got mean 1 and mean 2. I think now we can get the pooled variance. So the pooled variance is going to be equal to, and you have to do this in parentheses, the sum of the two sums of squares and then that's got to be in parentheses because you add those first and then you divide by the degrees of freedom for each one. So I don't have that in a cell. I'm just going to type 7 plus 7 because I can see above that I typed this out. If you just click on this cell, it's not stored as a number. That's text up there, and so it's not going to divide right. I know the degrees of freedom are 7 and 7. In the next problem, I'll create cells for degrees of freedom. Okay, that's our pooled variance. So now we can do the estimated standard error, which is S sub M1 minus M2, and that's going to be equal to the square root of this quantity. First, it's the pooled variance over N1, which is 8. Don't get N's and degrees of freedom confused. And then we add this quantity, so another set of parentheses, which is S2P over 8 again. Then we'll close that parenthesis. Then we got to close the main parenthesis. See how it highlighted that that parenthesis closes out the square root function? Now we're ready to go. That's the denominator in the t function. So now we can calculate t, right? And let's just align these right so that they'll look good. Bold them. Okay, what is t? T is equal to, and we got to do this in parentheses again. First you do the mean subtractions. Mean 1 minus mean 2 divided by the estimated standard error of the difference between the two means. Okay, so t equals 5.04825. We can actually reduce the number of decimals there. It's 5.048. And let's compare that to 2.145. It would be helpful, I think, if we like imagined that this number here bordering the shaded area is plus 2.145. We should actually say that is plus or minus. .145, right? And then this region over here, let's zoom in on this a little bit. All right, this region over here, that's at minus 2.145. So where does 5.048 fall? Well, if 0 is in the middle and 2.145, positive 2.145 is there, then 5.048 is going to be to the right of that, somewhere over here in the shaded region. That means we reject the null hypothesis. So step 4 is decide. And what does that mean when we reject the null? Well, let's see. We got a positive number for t, but we subtracted team A minus team B, which means that team B had a lower average score than team A. But let's go back to the problem. What did they measure? Minutes needed to run around the track once. Well, that means that team B took fewer minutes on average, 3.5 minutes versus 10.75. And that means that computer-assisted training actually reduces the time it takes, right? So we could say the team using computer-assisted training ran significantly faster than the team using the old-fashioned way. And then in APA style, we do this. T with 14 degrees of freedom was equal to 5.048, with a P being less than 0.05. We don't know what P was, but we know this less than 0.05 because that's what this table tells us, because we used alpha of 0.05. We know that a T greater than 2.145, our critical value, is associated with a P that's a proportion of area here less than 0.05 when you add the other tail. All right, and that is problem 1. I'm gonna save that. All right, practice t-tests, and I will upload this file as well as this video to the course website. See you next time.